So in this second hour, we are again coming back to talk about the polynomial regression. But we are trying to do that from scratch by ourselves. And so what is happening is we recall all the process. We have data x, and for simplicity, we just use n by 1 data. That's easier. Though you can make it bigger, like 2 or 3 features. But let's say in our class, this one is good enough. And we try to expand that to exex, so which means x squared, and xd. And after that, we run the linear regression. So we get C0, C1, up to CD. So that's the whole process. And therefore, our algorithm looks like this. The inputs contains a set of data, which is n by 1 array. And there is a set of label, and those are labels. And the difference between polynomial regression and linear regression is you can set up what is the degree, and degree is the highest degree that we want, the power, d. And somehow we can supply something like this. I will explain a bit later, but if you know this, then it is, let me write it clearly. I had a bad handwriting. So this means star KWARGS. Actually, what is the name? It doesn't matter. The thing is, what is star star? Okay, I will show you example later. So these are the keywords for linear regression. So you kind of can ignore this part first. Okay, let's just look at the first 3. And the output, it is similar to linear regression, and we have a predict, a function for predict, and a coefficient variable, and intercept. And intercept is C0, and the coefficients are C1 up to CD. And the predict, we will talk about this later. It will be obvious when we talk about the steps. So with this, we are able to write down all the steps, and it just try to finish the 2 workflows, 2 steps. The first one, try to expand the data to xex. The second one, try to run the linear regression. Okay, so the first one, I will just write it as the code. What you can do is you use x and then use star star, and notice that this is nothing to do with here. This one is the power, the power raised to certain power. Okay, and you want to raise to what power? We want to raise that to power 1, power 2, power 3, right? So we do np dot a range. 1 up to degree plus 1. Which means x is a column, right? And this is kind of a row vector. X will raise to the power of 1, x will raise to the power of 2, x will raise to the power of 3. And that's the first step. We'll show you example later. And the second step is try to run linear regression with, well, just suppose you have the linear regression function. You can use the code from the previous group, or you want to write it by yourself, that's fine. So use the linear regression function you had before and supply the data and supply the label and supply the keywords. So this one is going to be part of the definition of the function, and when you input the function, you will say something like fit intercept equal to true, and then it will be passed to this part. Okay, so it's like the whole thing is a function, and then you will absorb some of the keywords, and then you pass all the keywords to here. So anyway, it will be clear when we see the example. Just imagine that the big function has something that you have to take, and then you just simply pass all the things to here. Okay. Now, the last one is try to define what is predict. And this predict function, all you need to do is try to run through all the process above, right? You have x, you do xex, and then you do linear regression. And now you have x test, then you run expand that, and then do the linear regression. So if I have x test as a new set of data, then I can go through that and expand it into x test ex, and you know how to make it, right? And then after that, do x test ex, then you can do the inner product with the coefficients. And plus the intercept. So sorry, I did not mention. Once you run the linear regression, you will generate a predict function. But this is a predict function for linear regression. And you will generate a coefficient, and which is the C1 to C0, CD. And you will also generate intercept. And it is these coefficients and the intercept that you can use them to make the prediction, right? You have the data and then inner product with the coefficients and then plus the intercept, then you got the desired answer. So now let's look at how to make it work. So the good things that I'm doing on my computer is that I can also record the Jupyter. Okay, so I will continue with here and copy to the note later. Step 1, what you can, we basically write the syntax already, right? xex is equal to x star star and mp.arange. Arange 1 degree plus 1. So we have to set up something for our testing. We can set the same thing that we had before. X is equal to mp.arange, say 124, and reshape that into 3 by 1. So X is just an array 1, 2, 3. Okay. And we can also set up degree is equal to 2. And after that, you can see how does it look like. So what happens is we can print out everything together, okay? Okay, so you see that X looks like this, 1, 2, 3, and A range looks like 1 and 2. So it is again an example of broadcasting because the operator is taking the power, right? Raising to the power of certain, raising the power. And so it is raising all the thing to the first power, raising all the thing to the second power. So you get this column and this column. So uh, I will. I think you can you you can just try it by yourself. Just print the function. Okay. Now, second step is just run the linear regression. So you should be able to do that. All you need is to have the linear regression function from the previous group, or you write it by yourself. Now, the third step, once you have with coefficients and the intercepts defined, now we can do define predict function, define predict, and this predict you will take X test, and then what you are going to do is try to expand that do the same thing that we did before, mp.arange degree plus 1, right? And then you can make it. And after that, you are able to make the prediction. Y new is equal to this X test expanded and do the dot with the coefficient and plus the intercept. Okay, so with these steps, then you should be able to do something. I did not test that, and so maybe there will be some typos, but roughly that's the whole idea. And this predicts function allows you to generate some prediction after that. So later on, try to play with some code, and if for the middle part, you can simply use the package sklearn package, or you can ask the second group to see if they are already have some function available. But it's also not too hard to just write a function. Okay, so I will copy this. So take some data and try to see if you can make some of the steps work. And that's how you write write an algorithm. Okay, this is good, and I want to show you something more about the star keywords. Okay, that's a special things that happens in Python. So let me try to give you an example. Example of keywords. So this happens in many places. For example, just um, Anyway, let me try to do this. Okay, so you can define the function f, and you can set up what is x, set up what is y, and set up something like math is, uh, and set up like keywords. So this looks like really weird. You never seen, probably you haven't seen this before, or you see that but not sure what does that mean. So let's try to do something first. You can try to print x equal to x, right? And see what is the input. Y equal to y. So you see it runs, and F13, and it is done. Okay, but now what happens here? So the thing is, sometimes you allow the function to supply a lot of things, and you don't really know how many variables that you are going to take. So this keywords is somehow similar to a dictionary of undecided number of keywords. And here is what I mean. Okay, so for example, you can say 1, 3, it is done. And of course, 1 will be x, 3 will be y. And what happens is you can also supply a new keyword, which is called math, and math is good. And you can say chemistry is equal to awesome, right? And these two are unexpected keywords, and sometimes the user will input a lot of things and you don't know what they are going to do, right? Sometimes they do 2 keywords and sometimes they do 3 keywords. And let's do one more. Bio is fantastic. Okay, so you see it still runs, but let me show you how does that look like. So now keywords is a dictionary. Let me see if I can print keywords. Okay, it prints. So you see that keywords with a 2 star star in the front, that's just a syntax. So this one means that once you supply a lot of things in the end, then all these things will be packed into keywords. And the keywords is becoming a dictionary. You can also print the type of keywords, and it is a dictionary format, right? And so these things, these things will record all the keywords that you have here, and then you can do it here. Okay, so what happens is if you have another function, let's say we define another function, print dictionary, and this print dictionary, you don't really know how many keywords you have, and you just again you take all the things here. And what you are going to do is for each item in keywords.items, print item dot item 0, and item 1. So what you can do is you can do print dict and then simply ship all these keywords into the next part, right? And what happens is you have all the things here and it is stored in the keywords, and then all these keywords is sent to the other function, and this function will unpack all these things and try to take that and try to do the corresponding things. So let me give you one more example, or rather than this one. So what happens is you can import from sklearn.linear import linear regression, right? Ready? A linear model, import linear regression. Okay, and you know linear regression has some of the parameters. You can do this, right? So there is one of the at least two keywords. One is called fit intercept. The other is called copy X. Okay, so for example, let's do this. So what you can do is you can set up fit intercept is equal to true, and copy X is equal to false. Okay, and once you run this, and then simply do return linear regression, and then send all the keywords inside. Okay, let's see how it looks like. Model is equal to this. Let me do that again. Okay, so let me explain this code once more. We define the function, and which is called f, and it takes x and y, and we print out what is x and what is y, and it has nothing to do with linear regression. And after that, we collect a lot of keywords, and we send these keywords to linear regression. And you know, linear regression itself does contain some of the keywords like this, right? And it has fit intercept and the copy X, and then so when we do this line, then it will try to run print X, print Y, and then generate a model with this setting and send it out. So once this is done, model, you can see how does it look like. It is a linear regression model with copy X set to false, and you can get all parameters. Then you will see, oh, okay, fit intercept is set to be true, and copy X is set to be false. So that's the idea of using the star keywords to pass a lot of keywords to the other function. So I will leave it here. Okay. Okay, so this is an example of how to use the keywords, and hope you can know better about that. Okay, and so I will stop here. Let me stop the recording first.